Good afternoon. Please take your seats. So we are coming close to our final talk and reflection that will end the beautiful day we've had. And I want to invite my co-chair, Irit Barzel-Rave, Irit, which is a senior clinical psychologist and an organizational consultant, and she is the founder and the chairperson of our forum and a wonderful and inspiring lady to all of us, and thanks to her, a lot of us are here today and in general. Yeah. And of course, she is a founder member of of the International Society for Neuropsychoanalysis. So, Irit, please.
We are sharing it together. You're not going nowhere. Okay. So, can we ask Oliver to give? Let me say in some words what we are going to do. Oliver is going to give us a beautiful, very interesting talk. Neuropsychoanalysis of mind, and then we will invite Professor Yona Rosenfeld, who is my dear mentor and friend, and I will have another chance to say it again later and to explain who he is and something about you, you know, except of being a social worker. And then we'll do, and Yona will do the reflection as we used to do every meeting. As we finish the meeting, we have another, usually every meeting we have 15 minutes for reflection about the meeting. In this reflection, usually we try to see what did it contribute to us, what the whole meeting, the whole day, how did it make a difference, whether we could have taken something into our practice. So Yona is the designer and all the owner of all these ideas, so he will explain in some words how this whole thing of the reflection came up. And then I will say some closing remarks.
Everybody, thank you very much. I hope you can hear me again reasonably clearly. So for this last talk, I thought that I would not spend too much time going over research that I have already published, because you've heard all about that, for 2 hours earlier this morning. But instead to try to think a little bit about what the nature of the mind is, and also then to discuss what the implications might be for various things that we think are very important. So apologies, there may be some people in the room who know some of this material, but hopefully not all of it. So firstly, I'll talk briefly about what is the mind, a surprisingly complicated subject for some psychologists. And the brain basis of this interesting phenomenon, which I hope will be interesting. And then I would like to discuss 3 implications for if these facts are true, what does it mean for 3 things in the world? Freudian metapsychology, and the conscious id idea that Mark Solms has been interested in discussing in the last couple of years, for very early child development, which I think including the in utero aspects of child development, and for animal minds, in no particular order. I forget which order they're in there. Some of these ideas are potentially a little provocative, I think, or could be regarded as provocative. Do animals have minds? Has all sorts of implications, and the minds of very small children are provocative as well. I don't mean that I take a particular moral stance on any of these questions. In fact, there already many people have taken moral stances on these issues. I only wish that as a neuroscientist we can add some evidence to these issues, because I think often these decisions have been made without evidence so far. So I hope that isn't too cryptic. Are we ready for me to get going? Okay, so here we go. So what is the mind? If you have a look in dictionary definitions, well, firstly, the mind is surprisingly hard to define. I have a little game that I sometimes play with undergraduate students who have just finished doing a psychology degree, and you say to them, tell me what a mind is. And it's amazing. You can even do it with some academic colleagues, and they stare at their shoes, because you have just finished a psychology degree and you can't tell me what the mind is. It's a little difficult, I think, and challenging for us as a discipline. If you have a look in the dictionary, there are 3 elements that are present in some or all definitions of the nature of the mind. The first of them, which is universal in definition, is that it is about first-person conscious experience. So you are the subject, the heart of your entire play. You are the Hamlet in your play. You are the most important thing in your subjective universe. And in this sense, you have awareness from a number of different aspects of sensation. And more importantly for us, this experience comes with valence, with a positive or a negative valence. It has a feeling, emotion attached to it, which brings it a certain color or flavor. That definition is always there when people talk about mind. Then there is a lot of definition of mind, but not universal, which defines it in the context of intelligence. That is, problem-solving, imagination, goal-directed action. Things which mean that you have to be clever in order to have this aspect of mind. It's not every definition that has it, but it's reasonably common. And then thirdly, and probably the least common of the three, but present in a lot of definitions, is a sense of agency. So you could imagine, for example, being a first-person subjective experience. That is, you could be the passive recipient of being conscious, but not be able to move your mind and use it for various tasks. But clearly, being a mind involves, being able to think about what it is that you would like to think of. So this volitional free will element is also very important. And I'm going to spend a little bit of time talking about those properties and what we know in modern neuroscience, and then I'll talk about some of the implications for that. So let's talk then about which brain areas we need in order to run mind. Mind is a big word, so the problem needs some sort of simplification, and I'm going to attempt a simplification. So the first one, which as everyone in psychoanalysis will know, is a problematic simplification. But let's imagine that mind was the same thing as consciousness, and I'll come back to this later, but let's just make it easy for ourselves and talk about the conscious elements, the subjective experience elements of mind. As we know, there's an important distinction that's often made in philosophy and in the mental sciences between the easy and the hard problem of consciousness. David Chalmers is the man who made this distinction in Australia. Well, he's an Australian philosopher a couple of decades ago. And it is, as I think most people in our field know, a distinction between which parts of the brain are responsible for producing mind, which is, of course, the easy problem. And I think it's safe to say that we have some answer to this question. I don't say it's a perfect answer, but I think we have not a bad first attempt at understanding which brain areas are responsible for mental thought. And then there's the second question, usually described as the hard problem, for which we don't have an answer. And that is, how is it that these brain areas produce mind? The analogy I always think of is to think of the cells of my liver or my kidneys or my heart, which have, cell membranes and vesicles and endoplasmic reticulum and the cell nucleus. But my liver, as far as I know, is not terribly conscious. But in my brain, I have effectively the same sorts of materials with, membranes and nuclei and endoplasmic reticulum. But somehow these bits of my body manage to produce mind, and my liver doesn't seem to manage conscious awareness. So there's some incredible trick going on here, which I think it's safe to say that no one in the world has very clearly understood. Otherwise, I think there's a Nobel Prize in this. The problem of consciousness is very important for us. It's the big prize in our field. And by the way, maybe I'll talk later if someone asks me a question about the moral implications of this. I have a very strong position to take on the distinction between artificial intelligence and artificial consciousness, and whether we should be promoting one or the other. I think it's an important question for this century. So let's imagine that we're oversimplifying the world so that we consider consciousness to be the bit of the mind that we're most concerned about. Then consciousness comes itself in very many different varieties. Damasio is one way of cutting up this cake, although other philosophers have divided it up in different ways. But I like Tony Damasio's definition, which is this distinction between what he calls core consciousness, which is the simple sense of being sentient in your body at the heart of your universe, which you are all, of course, able to have now, but needn't be associated with any of the clever parts of consciousness that I described earlier. He describes those parts as extended consciousness, They are, you know, the various perceptual modalities and memory and attentional capabilities and problem solving and so on. I like to think of it actually in a sense, maybe I just travel too much, but I often wake up in a hotel room on the other side of the world somewhere, which isn't where I was asleep the night before. And when I wake up, I have no idea where I am. I'm disoriented. Maybe other people share this experience. And for a few seconds, I need to work out where in the room I am, where the room is. You know, I'm not sure I could even answer the question of who I am at the time. But I know that I am a thing, you know, that I'm sentient and I'm the thing that is doing the thinking, the old cogito ergo sum of Descartes. I think that's, for me, the best time in my life. Well, not it's a bad time, but it's the time that most closely associates core conscious awareness, but without these problems of extended consciousness. And it takes my brain a couple of seconds, or sometimes maybe even a minute, to sort of reboot itself and get all of the modules in place so that I'm able to think cleverly. But from the moment of consciousness, I knew that I was where I was, and I could tell you whether I was feeling good about that or not. So I think a very important, an important distinction. So, you know, you might imagine that in this wonderful world of new technologies, that we would be able to use all this new technical equipment to try to answer this important question. But actually, I think that the truth is that we have known the answer to this question more or less for 50, 60, 70 years or so. We might not have known all the exact details, but we have a very good first pass at the potential answer. And we have known that from one of the older techniques which we use in modern neuroscience, which is human lesion neuropsychology. So we can ask which brain areas of the brain need to be damaged in order to lose consciousness, or let's reframe it, you know, which brain areas can you damage and not lose consciousness? And then we can work our way through the whole brain and see what's left. You know, that seems a nice way to try. Now, in a sense, what I'm doing for you in the next 3 minutes is a sort of a summary of an undergraduate neuropsychology course, but it's just the highlights of it, but it's worth thinking about. You know, let's remind ourselves, maybe consciousness, core consciousness, is in the frontal lobes. So here's the most famous frontal lobe patient in history, Phineas Gage, 150 years ago, and I invite you to discuss whether he's conscious or not. So the first person on the scene said, I mean, we all remember the story, the terrible tamping rod accident in a railway in New England. It goes through the medial part of his frontal lobes. He gets 2 of his doctors who turn up at the scene. The first one says, Mr. Gage, during the time I was examining this wound, was relating the manner in which he was injured to bystanders. And later Harlow, the man who wrote the case up in 1848, said, the patient bore his sufferings with the most heroic firmness. He recognized me at once and said he hoped he was not much hurt. Wow. He seemed perfectly conscious, but was getting exhausted from the hemorrhage. So, you know, only the most hard-hearted and cruel individual would claim that Phineas Gage is not conscious. Here, he is clearly sentient. It might be that he could have a little bit more insight into his injury, because I imagine when he says, you know, he hoped he was not much hurt, once that thing's gone through your skull, you know, your chances of emerging unscathed are not very high. But I'm prepared to believe that Phineas Gage is sentient in this moment. So I don't think it has anything to do with the frontal lobes, is my first claim. But other parts of the cerebral cortex are available. So let's see whether language is very important for this process. Here's the most famous patient in all of the physiology, Broca's original Tan or Le Bon, the patient in the Salpêtrière, I think, who had famously all of the softening around Broca's area and other areas around the Sylvian cortex on the left cerebral hemisphere. And here's Broca's report. He could no longer produce but a single syllable, which he usually repeated twice in succession, regardless of the question asked to him. He always responded tan, combined with various expressive gestures. This is why throughout the hospital he is always known by the name Tan. So, you know, he can't talk, but if he wants the salt from the other side of the table, he points to the salt and makes a salt demonstration, and someone passes him the salt. Personally, even though he can't speak, I'm prepared to give him the benefit of the doubt. I've met many aphasic patients across my lifetime, and I don't want to be the one claiming that patients with aphasia are not conscious. So if we don't need the frontal lobes, and we don't need the left cerebral hemisphere, you know, It's more of an undergraduate neuropsychology course, this, so maybe memory is very important. So what about patients who have bilateral lesions to the medial temporal lobes? The most famous patient here is HM. Here's Brenda Milner's account of HM. I remember him as extremely gentle, very cooperative, with a good sense of humor. He would tell jokes. Of course, he'd tell the same jokes over and over because he couldn't remember that he told them before. So, I agree. He probably didn't make people laugh quite as much the second or third time that he told the joke. But is he conscious while he's doing it? I don't want to be the person to say this is not a man who's conscious. And so I could go on through undergraduate neuropsychology, wiping out various parts of the cerebral cortex, and in each case showing how, if we go back to Damasio's distinction, showing how those patients lose a little bit of extended consciousness, and because the cerebral cortex is relatively modular, it's a different part of extended consciousness everywhere we go, but in each case, all of the rest of conscious awareness seems to be intact. They just lose one particular skill, one particular modality. So what's the logical conclusion that we can reach from that? Well, what's the most extreme case we could find? Someone with no cerebral cortex? Well, those patients are available. And they belong to two different but related categories. They are either anencephalic or hydrancephalic children who in utero have a range of possible causes, which means that the most common cause is enlargement, chronic enlargement of the cerebral ventricles, and that means, as you can see over here, that all of this territory, about 90+% of the cranium, is filled with cerebrospinal fluid, grossly enlarged ventricles, so that there is effectively no cerebral cortex left. There's a little bit of cerebellum, and maybe over here the tiniest back bit of the occipital lobes. And when I teach undergraduates this sort of stuff, they sometimes ask, well, how can they be alive? How can you lose 90% of your brain and still be alive? And the answer is, we just need a brainstem. So long as you've got a medulla, which is there to regulate blood pressure and internal heat regulation and blood sugar levels, and some other parts of the brainstem, you can be perfectly alive. And then we can ask ourselves, what are these patients like? Well, two things spring to mind most clearly. The first of them is that they are profoundly, extraordinarily learning disabled, as you would expect, because they've lost all of extended consciousness. They've lost all of those modules, not just like Phineas Gage or Tan or HM. They've lost all of those bits from that part of the brain. So don't expect them to be learning language or remembering things or being able to make complex decisions. But I'm not here to talk about the clever bits of the mind. I'm here to talk about consciousness. I'm interested in core consciousness, not extended consciousness. So we can ask ourselves, are they conscious? And it's a hard question to ask, but here's a quote from a fantastic review paper by Merker a decade ago. This is a patient over here who is at first having her younger sibling placed in her arms. You can see she's not making eye contact because she's blind. She's cortically blind, because she doesn't have primary visual cortex. She does, might have some residual vision in the upper brainstem, but that doesn't produce conscious awareness. So here she is, she's looking around, but she can feel things, and her sibling is placed in her arms, and here, good heavens, she's smiling. Or at least you might argue that she's producing the facial musculature which is associated with smiling, you might say. Here's Merker's quotes on it. These children are not only awake and often alert, but show responsiveness to their surroundings in the form of emotional or orienting reactions to environmental events. They express pleasure by smiling and laughter, and aversion by fussing, arching the back, and crying. So they are showing behaviorally the things which we might reasonably expect someone to be expressing when they are experiencing some sort of conscious awareness. There are also autonomic changes that go along with this process. The question is, are they conscious or not? And of course, because our definition of consciousness requires language, it's a very hard question to ask, and I will return to this in the animal minds question. But is there a possibility? Are they at least technically able to be conscious? I think that they should be allowed at least some consideration in that category. And why are they conscious, we might ask ourselves? Well, I said we've known for 70 years the answer to this question. There was a lot of lesion work done in the middle of the last century, a lot of it trying to investigate the processes of sleep and to some extent dreaming, if we can investigate it that way, especially in cats. Always good to do this research in an animal that sleeps a lot. And by systematic removal of various parts of the cerebral cortex, the original investigators were able to see what happened. Were they still conscious? And yes, of course, you can take away successively all of the cerebral cortex in cats. They become a lot less clever in this process, but they remain conscious. And finally, when you get to the upper brainstem and the pons, upper pons and midbrain, then suddenly these cats start to lose consciousness and become, they look as if they're asleep or in a coma, if that was the word you would like to use to describe it. So is there converging evidence from humans, not just cats? Well, yes. We now know the critical lesion site for loss of consciousness, that is coma, in human beings. Here, this is the work of Pavisi and Damasio a decade or so ago now. Is one of the many patients that they surveyed in the review paper. What you see over here is a fantastic preservation of all of the different parts of the cerebral cortex, beautiful cerebral cortex, but a lesion over there, which you can see highlighted over here in the pons to upper pons to midbrain section, and there's a loss of consciousness. This patient is in coma, despite the fact that all of the cerebral cortex is intact, but they've lost a little bit of the upper brainstem. And remember that in all of us, your brainstem is about the size of your thumb. It's nicely size scaled, because if you're a small person, you have a smaller thumb, and vice versa. So these people have lost the top part, some part of the top part of their thumb. That's all you need in order to be able to lose consciousness in human beings. These are the lesion overlap diagrams for the Pavisi and Damasio study. It gives you some feel for what the critical brain areas are. If you want to look at the nuclei that subserve these, here's a sort of a cartoon diagram of the nuclei of the brainstem, and you can see a range of nuclei distributed across the pons and midbrain, which seem vitally important for the maintenance of consciousness, and lesion to these brain areas produce coma, is the short answer, and are responsible for making you fall asleep at night, which is when, of course, you lose consciousness. If you ignore dreaming, which is a special state, then I don't remember anything from when I fall asleep. I fall asleep and then boom, I wake up and time has passed, and I haven't been sentient during that time period. And of course, for those of you interested in other causes of coma, anything which compresses the midbrain, for example, like large space-occupying lesions or swelling as a result of a traumatic brain injury, compresses through mechanisms that we understand in neurology and neurosurgery, the upper parts of the brainstem, and therefore produces loss of consciousness. So, just to recap what we've talked about, assuming that mind is consciousness, which I agree is a but if you'll give me half an hour, I'll talk about some more about that. And assuming that I'm only interested in the easy problem here, I just want to know the brain basis of it, how the miracle happens that turns these cells into consciousness, I don't know, and I'm not, Stockholm hasn't phoned me up to give me a Nobel Prize yet. And assuming we're interested in core consciousness, then I think we know what the answer is, that the biological basis of core consciousness in human beings is mediated by the reticular formation, or the ascending reticular activating system in the upper pons and the midbrain. But that is, I think, just the first of the three items. You remember at the beginning I said I'm going to talk about conscious awareness and agency and intelligence. So, we can say a bit more about agency. In fact, I did was it the first talk today, in which I said that there's these dopamine-producing fibers that project forward from the upper brainstem, that we can augment these things that give us enthusiasm by adding dopamine, which I don't recommend doing for recreational reasons because it's bad for you in the medium term, but it will increase your enthusiasm temporarily. And I said also that lesion to these brain areas, particularly with von Economo disease or encephalitis lethargica after the Spanish flu epidemic at the end of the First World War, produces these loss of inertia cases, of which I said Oliver Sacks and the Awakening story was the best example that I know. So I think amazingly, the second part of the equation, that is the feeling of agency is run by the next door neighbor of the upper brainstem. So that upper brainstem has the bit that makes you subjectively conscious and the bit that allows you to feel agency. It's quite a remarkable situation in which the key aspects of mind are located in very old bits of the brain, and that is, I think that's not, it's an important fact for us to know philosophically. So now I turn to animal minds because I can talk about intelligence. Sorry, let me have a little drink. So which parts of the brain are responsible for the other part that I said is in dictionary definitions, intelligent, creative, decision-making, imaginative aspects of mind? Well, you might well argue that it has something to do with the new, clever, extended consciousness outside parts of the cerebral hemispheres. And indeed, as you can see from these, evolutionary series arguments, we are indeed owners of much bigger cerebral cortices than these less intelligent animals on the left-hand side. And you might well argue that the more you've got of this new, clever, enfolded cerebral cortex on the outside, the better your chance you have of winning this intelligence contest. But remember, intelligence is only one of the three dimensions which I'm trying to build here, and we must not forget that. So what about the other ones? Well, as anybody knows who studies comparative neuroanatomy, we know a lot about what happens to the brainstem across evolutionary time in relation to the cerebral cortex, and the short answer is conservation. The rule, for those of you who are not familiar with comparative neuroanatomy, is that we can never be allowed to have a brain 2.0, if I can use a computer analogy. If you're an engineer, you can scrunch up the old model, throw it in the bin, and build a new, better one. But the problem in evolution is if you scrunch it up and throw it in the bin, it dies and doesn't work. So the answer for evolution is you have to keep the old bit that works, and you have to bolt new modules on the old thing, but don't change the old thing because it worked. You can't make that risk. So the brainstem is extraordinarily conserved across evolutionary history. Here we see, from reptiles through birds, through early mammals, across to human beings. We see no change effectively in the design of the brainstem, but we see a lot of new stuff, new modules being bolted onto the outside. Yoram talked about this material earlier, and I think in comparative anatomy terms, that's we can almost take that for granted. But I said earlier that the upper brainstem and the pons is responsible, or at least anatomically, we think, is responsible for the biological basis of conscious experience. So that has implications. It has implications for how we consider sentience and what sentience looks like across animal species. Now, we have had, for various positions, for various reasons, cultural attitudes towards non-human animals, which are interesting and inform our decision making. As I said earlier, it's not my desire to tell you what we should do in relation to this. I'll give you a bit of advice about our options in a few minutes. But I just want to add science to the equation. We might have a special reason for why we think human beings are special and unique. But if you think that consciousness is the reason why people are unique, then you've got to explain this continuity of the brainstem problem. And in fact, I'm always reminded of Descartes. You remember, perhaps as undergraduates, how Descartes identifies the pineal as the brain area which mediates between the soul, the immortal soul, and the physical brain. But Descartes, who went next door to do his dissections, knew from the dissections of sheep that sheep have a pineal. So what do? And if you read Descartes, he said, sheep have got a pineal, but they don't use it. So, we all need to be able to justify our decisions for one reason or another. I only ask that we think a bit about the neuroscientific evidence here, which might inform the way in which we might approach problems in the world. This is still a very live debate, by the way. Here's Brian Key, who I don't like very much. writing, an Australian biologist who wrote last year, just to give you a feel, on why fish do not feel pain. So the logic of his argument is pain requires the cortex, fish lack a meaningful cortex, and he then goes through all the areas of the cortex that he thinks is important for pain. Therefore, fish do not feel pain. And thank heavens that Damasios, Tony and Hannah wrote a response to this, which is, that pain requires much more than the cerebral cortex. And he identifies, reminds us of these brainstem areas which are centrally involved in reticular activating system and other areas, which of course are present in fish. Therefore, they're not guaranteeing that fish may well feel pain, but they're entitled to at least. We can't use the biology argument in order to draw the conclusion that fish don't feel pain, I think would be the argument. And last year, just to show you what a live item this is. So in another version of this talk, in which I talk only about animal minds for an hour, I run through all of these classes of evidence in order to try to demonstrate, what evidence there is for animal minds, starting with the cleverest, more sentient parts of the mind, and moving towards the more emotion-based aspects of mental life. I don't have enough time to do all of that, but I can give you the greatest hits. So let's talk about, and in fact, I'll give you my summary first, because that will explain everything that you need to know, even if you didn't have the greatest hits. So let's imagine that you defined mind as things that are clever, complex, clever stuff, Then you are discussing processes that happen later in human evolution, like the things we teach children in primary school. That's what I mean by later, reading, writing, arithmetic, those sorts of stuff. And we know that these brain processes are mediated by various parts of the cortex. That's the job of cognitive neuropsychology, really, is to work out which parts of the cerebral cortex do what. If you're going to define mind as cleverness, then I have the following prediction for you, which is what the literature basically shows. That is, you will find this way of defining mind only in a few species of animals. And you will find it in those species, not in everybody, but only in the Isaac Newtons of that particular species, the cleverest, brightest members of that species. And you will achieve this level of aspiration only after really a lot of practice. You're going to have to put in the hours of training and learning in order to make this achievement. If your definition of mind is intelligence. But maybe you could have another definition of mind. How about if your mind was based on much simpler, more affectively mediated experiences, which I hope you can agree are present in early emotional development. You don't have to go to primary school before you feel emotions. When I spend time looking at children, and I was on an airplane 24 hours ago, so you know exactly what it's like when there are children that are distressed. Those are very early experiences. They're there from the very beginning, as far as we can tell, and they are mediated, of course, not by subcortical systems. So if this is going to be your way of defining the mind, then my prediction is, firstly, that you will find this aspect of mind in many, many, many species. And you won't have to be Isaac Newton of that species in order to have it. It will be universal amongst the members of that species. And thirdly, you won't need to put in all the hours to train the animal how to be emotional. They will be emotional from the get-go because it's an inbuilt, hardwired system. So that's my sort of summary. Then I thought to view the animal minds literature through this lens, and here are some of my favorite hits. I like Irene Pepperbird's Alex the Parrot. I haven't put any videos in here, but I highly recommend YouTube if you want to see. Hands up anyone who knows about Alex the Parrot. Okay. Is he fun? He's very fun, I think. So he's no longer, alas, with us, but he can name 50 different objects. He can count. He can distinguish colors and shapes. He can do comparative differentials. He does personal pronouns very nicely and understands what 0 is. And on formal testing, his accuracy is about 80%. I say 80% because, as you'll see on the videos, he's not perfect because that data doesn't account for sarcasm. He's like a petulant teenager, Irene, like a good experimental psychologist, wants to collect a lot of data, and after a while he gets bored, and he starts to produce results, which are just patently wrong, things that he got right 10 minutes earlier. You'll see some examples in a moment. He does turn-taking in conversations, amazingly. If he repairs relationships. So if she gets upset with him, he says, I'm sorry. And he gets frustrated like a teenager. So if he says, want a banana, because he speaks with, I think, a Brooklyn accent, but instead is given a nut, which is a lot lower status for him, he kind of glares at her. You see her looking, saying, come on, didn't you hear me? Or throws the nut at her. And his last words, he died, unfortunately, of something cardiac, we think, in 2007. Her last words before going to bed at night, you be good, see you tomorrow, I love you. Which is quite something. So now there are some counter arguments to that which I don't have time to go into, but Alex is fantastically impressive.
I want to say he was chosen occasionally in the fact he wasn't the clever parrot. He was chosen occasionally in the.
That's true, but I think he was an Isaac Newton. She has other parrots, and none of them have been as clever as Alex. But I agree with you. No, I don't think he wasn't specially bred for cleverness. He just happened to. She found a clever parrot, which is. Yeah, you see, if I was giving you the whole talk, I would then show you the next slides, which demonstrate. I'll give you the counter argument. So, no, let me answer the question. You asked me the question. Let me answer the question. Okay. So, the answer, the parroting answer, is clever Hans. You remember the famous story about the horse that could count, and he couldn't really count because when he wasn't able to see his trainer, or his trainer wasn't there, because he used to just, whenever the trainer looked at his hoof, he would tap until he got to 13, and then the trainer looks at his face and he stops. Alex can do everything you said here earlier with other members of the team, and indeed you can see novice videos. So someone who's never met Alex before, you go in, you can have a chat with him. So it's not the same associative learning argument as clever Hans. But let's remember, I don't care. Actually, whether you're not convinced by Alex's cleverness, because I'm not interested in cleverness, really. I'm just showing you that I think he probably passes cleverness, but that's not the heart of my argument, is the short answer. So let's try different species altogether. Bottlenose dolphins. Who's familiar with sponging in bottlenose dolphins? Nobody, or a few people? Okay, they're remarkable. They are, I don't know if you know, they're found only in Shark Bay in Australia, where the bottom of the sea, with what fish do, they hide those flatfish underneath the sand, and dolphins can sense them using their sonar. You just need to nudge them out in order to eat them, which is great. But the problem is the bottom of Shark Bay is covered in coral. So if you've got a nose and you stick it into there, you're going to injure your nose with coral. And the answer is condoms. So these basket sponges, which are conical, a very clever dolphin discovered that if you dislodge them from the bottom and you put it on the front of your nose, then when you nudge the fish out of the bottom, then you won't damage your nose on the coral. They're quite remarkable. But remember I said it's an Isaac Newton phenomenon. It's only found in Shark Bay in Australia because one very clever dolphin discovered it, and also it has matrilineal transmission. So it's not all the dolphins who do it. Sorry? Have they discovered it? Oh, well, I'm very pleased that there are clever dolphins in Eilat as well. Do you have conical sponges? So there's more than one Isaac Newton in the dolphin world. But I mean it only to say that there aren't, they need to be discovered by someone clever. Anyway, I'm going to keep moving. But this phenomenon of cleverness, of course, is not unique to, is not unique to dolphins. Here are some different example, a problem-solving example this time. Have you seen these videos of squid taking out crabs? So this is a crab in a screw-top jar, which is filled with water, seawater, and it's thrown into the octopus's tank. And the question is what the octopus will do. The answer is that they put their body around the top, they unscrew the container, and then they use their paralyzing saliva to kill the what's it called again? Crab, that's the word I was looking for. And then there we go. In the study that I'm citing over here, which was done quite a while ago, there were 20 animals in which was attempted. They've never seen, in nature there's no such thing as a screw-top container. Of 20 animals that were exposed to it, 19 were attempted. One of them is presumably a bit of an anxious octopus who decided not to give it a go. Of the 19 who attempted, all succeeded at their first attempt. And this is the graph over here over time. which demonstrates that if you repeatedly expose them to them, they get their performance down from about 1 minute to open, from about 3 minutes to open to about 1 minute to open. So, remarkable experiences. Well, we'll talk about octopuses in a second. Okay. Yeah, I'm coming to that. I promise you, give me 10 minutes, I'll get there. Okay. So maybe we care about self-awareness, So there's a mirror self-recognition, the Rouge test. Everybody in the room is familiar with the classic test passed by children at about 18 months. You daub the child with something and then you see in the mirror. Has it been done in animals? Of course it's been done in animals. So in all the great apes that it's ever been done with, they have a very high success rate, not 100%, but quite a high success rate. And it's been managed for a lot of other species besides. Okay, so cephalopods, you're quite correct. My heckler over there correctly anticipated that we have a problem here, ladies and gentlemen. I was giving a good argument about the brainstem, which is continuous across evolutionary time, but the cephalopods are an entirely different, an entirely different development. They are there from before the Burgess Shale. What is that called again? What's it called again? The Cambrian explosion, that's the word I was looking for, which happened 520 to 540 million years ago. They're an independent class of evolution, and they've got great big brains, but a very different design. They have this distributed brain, as I presume you realize, in which each arm has its own brain. There's fantastic literature demonstrating here that you can decerebrate them, you can remove the central brain from the brain that's in the arm, and the arm still works and reaches out and grabs objects, which is truly remarkable. But I'm afraid, as a human neuropsychologist, I'm stumped when it comes to their brain. They have a brain that consists of 2 lobes, the central brain, that is wrapped around the esophagus. It's an unusual place to have a brain, but maybe you can design things differently when you live in the sea. There's a small literature of EEG recordings in relation to these animals, which demonstrate that they appear to have things that look like sleep-waking cycles or changes in the depth of consciousness. But I think it's hard to even begin to answer that question. So here is a document signed in 2012 by Jaak Panksepp and some other colleagues called the Cambridge Declaration of Consciousness. We declare that, and I'll read out loud for us all here, that the absence of a neocortex does not appear to preclude an organism from experiencing affective states. Convergent evidence indicates that non-human animals have the neuroanatomical, neurochemical, and neurophysiological subsets of conscious states, along with the capacity to exhibit intentional behaviors. Consequently, the weight of evidence indicates that humans are not unique in processing the neurological substrates that generate consciousness. Non-human animals, including all mammals and birds, and many other creatures, including octopuses, also possess these neurological substrates. You might question the last sentence based on what my heckler earlier was saying, but I know what you mean. Okay, so on the basis of this, I make 5 predictions for things which I think will become more common during this century. I leave it up to you. I don't know what your attitude is towards eating meat. And in fact, I eat some kinds of meat. You can see how my attitude to it in here. But I predict that across this century, all 5 of these things will become more common. The first of them is improved living conditions for animals, for where the aspiration is the truly wild state, that they can live entirely unimpeded, and I think you can see some movement in that direction. If we must kill them and eat them, then let's slaughter them in ways that are increasingly humane and painless for them. Again, we are working, I think, in that direction. Or, if we are worried about eating sentient animals, then let's eat animals that are less sentient. Let's make a decision about how high up the scale, how much cerebral cortex you need, how much brainstem you need before you make an eating decision. Or we could generate the tissue, but without having the sentient being. And you'll all be familiar with the most expensive hamburger in the world. Cost 250,000 euros a few years ago, but the price will come down as we scale the problem up. It tastes like a real hamburger, and it's made from, cultured muscle tissue. And I remind you of 2 very important facts, which I think are important in the context of, climate change, I suppose, is one way of describing it. The first of them is the problem of flatulence. Cows generate a lot of bad stuff out of their behinds. And in fact, a lot of it is methane, which is much worse than CO2 as a greenhouse gas. Remarkably, the estimate is that about 18% of greenhouse gases are generated by livestock, and that's approximately the same size as the transport budget in greenhouse gas terms. So that's a remarkable thing to be thinking about. I know we all think about taking fewer planes and driving fewer cars, but maybe this. And the other part of it is, if we're going to tissue culture things, then we don't have to have the cows in the field anymore. Well, I wonder what we could do with our fields. Well, maybe we could put trees in them, and then we could have more Amazon rainforests everywhere. So you would get a kind of a double advantage from this model. So improve the living conditions, slaughter more humanely, avoid eating the cleverest, tissue culture them so you don't have to kill a sentient being in order to achieve this, and finally, of course, vegetarianism. I predict, and I haven't had anybody yet who'll gamble against me, that these 5 will become more common across this century. There's a whole animal rights issue that I won't get caught into, but there was a film last year, I think, called Unlocking the Cage, which is about whether you can keep great apes legally in the sort of phenomena that they're in. Okay, so that's my animal bit. What was that? That was a vote of approval from the back. Okay, well, I'm happy to take that endorsement. I want to talk briefly about child development as well. So if the core of mind is mediated by the upper brainstem, and assuming, and I grant you that in a syllogism, you have to agree that the premises are true in order for the conclusions to be true, assuming that the presence of a brain area is the same thing as it being functional, and I'll come back to that in a while, we can ask this very interesting question. At what age does core consciousness develop? It's very interesting. I don't see people writing about it, but there we go. And what's the case for the fact that that might be in utero, and if so, during which trimester? Maybe this is a fact that some people would want to know about. You want to know? Yes. Okay, there we go. Cortical development, you won't be surprised to learn, happens late in child development. In fact, gyri and sulci, it only gets tight enough inside that cranial cavity for them to develop in the last trimester, and they're incomplete close to birth. And indeed, I'll come back to myelination in a moment, they're poorly myelinated even at birth. Here gives us a rough idea though. So that at 37 weeks, that's not a bad approximation for an adult bit of brain design. But I'm not interested in where these are the wrong slices for me. I don't want to know about the cerebral cortex, and I'm quite interested in the thalamus, but I want a lower slice. So I've been searching the literature for you, looking for a lower slice. Are you ready? Yes. So there we go. That's what you want to see. That's the upper brainstem at 32 weeks of gestation. The cerebral cortex not looking very impressive, but for those of us who know our neuroanatomy, that looks disturbingly like the design of a midbrain. And if you have a look in this literature, which I've tried to do for you, the argument about development, of course, precedes anteriorly from very early development of the medulla, because you need a medulla to keep you alive. Then you develop the pons at about the 20th week, and midbrain only, quite close to the tail end of fetal development. Of course, yes. Well, I mean, I argued earlier that the core of the reticular formation is in the upper pons and the midbrain. So on that argument, then you might make a case for the 3rd trimester, I suppose. Who's to know? It's hard to argue. And remember, I said earlier, this assumes that presence equals function. Just because it's developed doesn't necessarily mean that it's working. I realize that I'm on sticky ground here, but I'd like to think about it. The other thing that makes brains work is not just having neurons in place, but having them myelinated. So let's have a look at myelination. Well, there we go. Myelination, for those of you who haven't remembered your undergraduate or postgraduate neuroanatomy, proceeds upwards, of course, from the brainstem. The first myelination is actually in the columns of Burdach, in the cuneate fasciculus, in the posterior columns. For those of you who are interested in myelination, we myelinate, or don't remember, we myelinate sensation before we myelinate action. So the posterior parts of the spinal cord get myelinated first, but that's a spinal cord area. There's no consciousness in the spinal cord. We get up to at full term, there's myelination, at least these studies argue, of brainstem, cerebellum, a bit of the internal capsule, and a few other very important tracts, and lots of the development, of course, after birth we're not interested in. So I think you could make a reasonable case. I'm no expert on myelination, but there's a reasonable case for a lot of very interesting stuff being in place, including being myelinated in the third trimester. So, you know, assuming that presence is function, maybe it isn't, but there we go. I think we can argue that you can have consciousness, core consciousness. It's not clever, but it's consciousness present in perhaps the later starts of pregnancy without very much cortex. I don't want it to, well, all I want to do is to bring science to the argument. That's my only case. And finally, in the few minutes remaining to me, I'd like to talk about Freudian metapsychology just for a few moments. Of course, cognition without awareness is a very old idea in psychoanalysis and indeed neuropsychoanalysis, but especially it's an important idea in cognitive neuroscience. For the last 40 or 50 years, cognitive neuroscientists have been arguing that there's lots of clever stuff that we can do without conscious awareness. Barge and Charkland's claim, they're a little bold to say it and take a guess, but you know, 95% of mental life, they argue, proceeds without conscious awareness. I could give you examples of all of these. You've probably seen them already. Here's the mirror tracing task that HM has to do, in which he traces between lines. It's a hard task to do when you see it in mirror reflection. Here's HM's performance across 3 days. He starts with a lot of errors, and he becomes flawless by day 3, or close to flawless. But of course, he doesn't remember doing the task. That's the point. In an earlier talk, I talked to you about how you can have emotion-based learning without conscious awareness in a patient who's profoundly amnesic. So let's just remind us about psychoanalysis and its attitude towards the unconscious, that the id is the bit of the mind that's laced with emotion and drive. I think everyone agrees with that. It's in every second one of Freud's iceberg diagrams, and of course the fact that the id is unconscious. At the same time, the ego for Freud is the resource of cognition, all of the different bits of attention and language and indeed memory. And in the Freudian, at least in these iceberg diagrams, the ego is conscious, or at least it's pre-conscious, available for access to consciousness. This is the classic position. But Mark, as you know, has been arguing for the last couple of years that actually Freud is right about the unconscious part, but he's just put the label in the wrong place. So that the data suggests, and I've talked about it all day today, that emotion itself is at the heart of conscious experience, and that it's cognitive systems, for all the reasons that I went through earlier, those are the parts, the cerebral cortex are the parts of the mind that are operating outside of conscious awareness. And we have the thing that Mark has talked about here, you know, which is a conscious id. Mark has then, of course, I'll talk more about this in a moment, a very difficult decision to make. You know, how do you defriend Freud? And Mark, of all the people in the world, has very good reasons to defriend Sigmund Freud. And the argument, I think, is that Freud was a child of his time. And I'll read you this, which you may have seen before. Freud, 23. It will be seen, he says, that there is nothing daringly new in these assumptions. We have merely adopted the views on localization held by cerebral anatomy, which locates the seat of consciousness in the cerebral cortex, the outermost enveloping layer of the central organ. So it seems, you know, in Freud's time, it was quite clear that human beings are one of the things that makes us special is that we're conscious. And the other thing anatomically that makes us special is that we've got a big cerebral cortex. So presumably that's the reason for why, you know, for why the cerebral cortex is run by consciousness. But, you know, the message of the last hour and the last day and all of, you know, neuropsychoanalysis reminds us that this is not the case. So Mark had this revelation in 2013 in Berlin. I wrote a little commentary on it, which you might find interesting, in which I asked the question about, well, firstly, it's called Facing Inconvenient Truths, because he's got a really tough job here. Here's the chance. Well, I'll read out to you. I said, what made me so shocked about this? And so the arguments are, firstly, that this idea was radically new and potentially revolutionary. But why hadn't he thought of it beforehand? You know, the idea was based on several really well-established scientific findings and seemed in principle correct, and I still agree about that. Thirdly, the idea ran central tenet of Freudian metapsychology. I hope you agree with that. The delivery of this idea by the current translator of Freud's Standard Edition was psychoanalytic and journalistic dynamite. Fifthly, why had I not seen this obvious line of thinking before, given that I already knew most of the foundational material? And seventh, why had Mark Solms not seen this obvious line of thinking before? Because by definition, he already knew all of the foundational material. What happened in Berlin, you know? And what was it in that morning in Berlin that precipitated this idea in mind. And then I finished the rest of the article by saying it was the contest between Bud Craig and Jaak Panksepp, and to some extent also Tony Damasio, who was on more or less on Jaak's side. There was a presentation, firstly from Bud Craig, saying the insula is where all the action is happening. The insula is where consciousness is, and Jaak, of course, as you know, does not believe that the insula is where consciousness is, and Mark was sort of forced to choose. And somehow, in the middle of this vexatious moment, he realized what the answer was, and then the pieces tumbled into place, and he realized the Freudian consciousness moment. I remember very clearly when he stood up and said, I've just listened to these people all morning, in the way that he does, you know, he writes things down on a scrap of paper and said, I'll only take 2 minutes to explain to you, and then 10 minutes later, he's still talking. And he said, I'm not sure if I understand this correctly, and then he laid out those ideas, and I think it's, at the time, as I said in the article, I think it's the most important speech in psychoanalysis in 50 years. I thought it really is very, very important. So, in conclusion, because we've now reached the conclusion time, you know, this is a very old problem, and we're facing some philosophical issues that we've been kicking around at least since the ancient Greeks, and presumably for as long as human beings have been, have been around. We have some new neuroscientific tools to bring to bear on this, and these have, I think, some important moral implications. Not that I'm claiming that science has precedence over other reasons for deciding about things that are moral, but at least would like us to bring our evidence to the game, because I think we have something to bring here. I don't think our position is entirely resolved yet, but I think because of the nature of what our discipline is, we have some material to talk about. We can hold up our side of the conversation, I think. And then I remind us all that we've only tackled the easy problem here. You know, there's nothing in here about the solution to the hard problem. I just do not know. I've got some ideas, but I do not know why it is that those upper brainstem areas seem vitally important for the generation of consciousness in my brain, unlike in my liver or my kidneys. You know, it's one of those problems that deserves a Nobel Prize. So on that basis, and I think on time, again, I would like to thank you all very, very much. It's been wonderful to be here.